The figure shown is the block diagram of the proposed circuit architecture, where it consists of the startup circuit, which its output is connected to the bandgap core. The bandgap core's output is connected to the operational amplifier, and the output of the operational amplifier is connected to the bandgap core. In this figure, this is the circuit of the bandgap voltage reference that we have come up with. Apparently, this is a conventional bandgap reference, but having the startup circuit. Each of these stages will be explained on the next slides. The bandgap core shown in this figure, we use two bipolar junction transistors Q1 and Q2 that have different areas in order to operate with different current densities. Three resistors are present in the circuit. The proportional to absolute temperature Ptat voltage is determined by the resistor R3 and R1, R1 and R2, where it has equal resistances. But by choosing the appropriate value of R1 divided by R3 ratio, the compensation of the temperature coefficients of Pt and BBE is ensured. So steady current through each branch becomes equal. The operational amplifier used in this circuit is basically a two-stage differential amplifier. So the main function of this amplifier is to drive the bandgap core, an operational amplifier which is designed in such a way that its output is insensitive to variation in supply. This helps to establish a reference voltage which is insensitive to supply. Shown are the specifications for the op-amp that we will implement on the bandgap reference, having a gain of 83 dB using the 0.18 micrometer technology and a supply voltage of 1.8 volts. During starting, no current flows in the bandgap circuit. Output voltage is 0, basically, so M4 here is on. It is mirrored with M3, so the current drain current of M3 and M4 is equal. This current is injected into the bandgap core, but as the circuit reaches steady state, source voltage of M4 becomes equal to the reference voltage, where it's about 1.2 volts. The bandgap design will be simulated using various parameters to evaluate its sensitivity to its surroundings. So the circuit will be constructed to minimize or eliminate the impacts of three main variables. Uh, Actually, there's two that may drastically decrease the efficiency of the suggested design and modify its output. So, namely, the temperature and supply variations. So, the equations here, which is the temperature coefficient and the supply variation, will be used to check the sensitivity of the circuit and in terms of temperature and supply. Shown is our targeted specifications based from our study, what we have analyzed from the data and methods that we use to target the goal of our paper. From the 18 nanometer, a 1.8 volts is used. For the 65 nanometer, a subthreshold voltage supply is used to power circuit. However, this may change in the future as we dig on more data and other techniques for the bandgap. But here we came to this upon studying and simulating the conventional bandgap and modifying it. Thank you everyone for listening.